Hello, and welcome to another episode of the Oxford Online Maths Club. My name's James, and today I'm joined by author Coralie Gomez.
Hi everyone. I'm Coralie. I have written a couple of math books. And just to tell you a little bit about myself, first of all, I'm in Mexico right now. So if you can hear the sound of waves, that's because I'm by the beach. And also, I'm a maths graduate from Cambridge. So sorry about that, James.
No, some of the best
And
people are maths grads from Cambridge.
that's great to hear. Um, and what I do in my day job is that I started and run Unifrog with my partner. So some of you might use Unifrog in your schools. And if you have any questions about that, I'm also very happy to answer them.
Uh, Miles in chat says, "Oh no way, it's the person who wrote the book." So I think you've got at least one fan in chat already. Hi to other people in chat as well. Who can I see? I can see Herb. I can see some anonymous people. I can see Ali and Oscar. I think I've got Srijan moderating chat today. So thanks, Srijan, if you're watching as well. Hi Zoe. I think. If you're joining for the first time today, you can join Slido chat, which is not on YouTube. It's on slido.com/OOMC. And you can be anonymous there. You don't have to make a Google account or anything. Oh, hi Zoe, there you go. If you join the Slido chat, you get to join it with a poll where we ask how your day's been, because I always want to know how many people's days have been. Courtney, how's your day been? You said you're near a beach.
Yes, my day has been great. It's actually quite near the beginning of my day. I mean, it's 11 a.m.
Oh, of course, time zones.
So yes, haven't done that much of it yet, but it's been so far because I can see the sea from where I am. Sometimes I can even see whales. I mean, really can't complain.
It's not fair. I'm in the office. I can see a building site. If you hear the sound of building site in the background, that's my bad. People are voting on how their day is. It's averaging out at 3.8, which is nice mathematically. Pretty good day, I think, at 3.8. I'd be happy with that. So the episode's title is Maths and the Law, and you're one of the authors on this book on screen, which is Math on
Yes.
Trial. Do you want to say what sort of things we're going to be talking about? There's some speculation in chat about what sort of law and what sort of maths we might be talking about.
I'll say that just first, I want to say that Leila Schneps, the other author, is my mother,
Aha!
and she is a mathematician. In fact, both of my parents are mathematicians, professional. So writing the book with my mum, we wrote this when I was 22. That was in itself quite an experience. But it was also super exciting just to get to research and learn about all these stories. So the book is specifically about 10 different cases, real life court cases that span like quite a few decades and also go across several countries. And it's cases where someone tried to use a mathematical argument as evidence during the court case, and they made a mistake in the maths.
I like the way your book has two taglines on it. Always better than one. How numbers get used and abused in the courtroom is pretty exciting. I don't know, did you invent one of these each, or is this a publisher's sort of thing? I did quite
It's
like
a
when.
publisher. In fact, it's just so funny when you're writing a book and the publisher sent you a cover and we both approved the cover and then they sent us the book and the cover had nothing to do with what they sent us previously and what we had approved. But I like the cover, so I'm fine with it.
Oh, so this is a sort of surprise for you as well. I shouldn't ask tricky questions
Yeah.
about. I just sorry. I really like when math becomes a matter of life and death. You better check your sums.
Oh, it's great. It's great. I love it. Makes it sound very exciting.
Thanks for voting in the poll, everyone. Hi, I hope you're having a good day. And at 3.8, I think on average, people are having an okay sort of day. Good afternoon, whatever time zone you're in. Somebody in chat asks, what was it like having mathematician parents? I think you mentioned both of your parents are mathematicians.
Yes, they are. I've always been surrounded with mathematicians. I loved it. I did try and rebel and study physics instead. In fact, I applied to study physics at Cambridge
Ah,
and did not get in. So the first time I applied to Cambridge, I applied for physics and I didn't get in. So I just gave up on my rebellion and applied for maths the following year. But I really loved it. My parents had, very different ways of getting me into maths. My dad would just send me a problem and then he would never give me the answer. There was no Google at the time. So sometimes it would take me years to solve it, but I got I got really motivated by that. And my mom was the absolute opposite. She thought there was nothing more fun than doing my homework for me, which sometimes was very useful. But yeah, she was extremely involved. So I enjoyed both of those. Didn't work with any of my siblings. None of my siblings did maths in the end. So only worked on me.
Fair enough. For some of us, doing maths, not a rebellion. For some of us, I like the idea of rebelling by, rebelling from the maths. People in the chat are trying to guess which cases you're going to talk about, or I think the plan is we're going to highlight a couple of cases from the book. There are 10 in the book. We're not going to cover all 10 of them. Each of them has got a kind of different maths error, I think you call them in the books, like a different fundamental nugget of what's gone wrong. I think we're going to try and do 2 or 3. If you've got guesses in chat, 13 Angry Men, the time that Indiana tried to define pi. I think that's what this is. I think it's...
I did not see that one, but my mom is always hounding me to write a sequel, so don't give her too many ideas.
A sequel, more maths on track. I guess like keep having trials, right? Until people learn from reading the book.
Yes. And things are quite different now. There's really often maths in trials because of DNA analysis. So there's a whole new area.
Yeah, big data's coming for all of us, I suppose. That everything's going to have large data sets in it. Okay, I think we've set the scene. This is Coralie. Coralie's an author with a maths book. Should we jump into discussing one of the cases? I'm gonna get you to take the lead. Partly because the noisy building work next to my window has just got closer. So I'm going to let you absolutely take the lead if people are ready.
Okay.
Oh, Oscar in chat mentions Humble Pie, which I do want to shout out very quickly, sorry. There's another book about maths mistakes by Matt Parker called Humble Pie, which is not courtroom based, but if you like maths mistakes, reading list.
And I also really like Matt Parker, who I've met lots of times because we've done some talks together. And yeah, he's great.
Jealous. Okay, right. Okay. Let's go with the case. You take the lead. Yes. I might write a bit on the whiteboard. Let's go.
Yes. So I wanted to start with a case where the math error is actually pretty simple and small. And actually the case itself is quite small, but it had a really big influence on how maths get used at trials even now. Because the error was so obvious and happened to fall into the hands of someone who became very influential later in life. And he basically got convinced through this case that maths did not belong in trials. So the story is set in 1968 in LA. And it's really just a small story. There was an old woman. She's walking along an alleyway, carrying her bag. And she gets pushed to the floor and her bag gets snatched. And she can see the person who's done it. It's a blonde woman who's wearing her hair in a ponytail. And the blonde woman runs to the end of the alleyway and jumps into a car. And there happens to be a man who's out there in his garden, and he sees her do that. And he sees that the car she jumps into is yellow, and the driver of the car is a black man. And he has a beard and a mustache. So the woman who got pushed and the guy in his garden, they go to the police and they describe what they saw. So this is a case where there's no evidence at all apart from a description of the person who stole the bag. But the description is pretty unusual, and the policeman thinks, well, there can't be that many couples like this, especially at the time. There weren't many interracial couples, and a yellow car is also quite unusual. So he figures, well, I'm just gonna go around to petrol stations and I'm gonna ask them, hey, is there an interracial couple who come and fill up their yellow car here? And he does that and he finds one.
I'm going to kick you here.
Great.
People who've seen the stream before know that my drawing skills are legendary, and I'm relishing the chance to have a go at a yellow car.
This is very exciting. It's very exciting for me.
Oh my goodness.
I've never had this before. This is much better than what normally happens.
Stop live stream. You don't get this with everyone. What do cars look like? I need to draw like a stick. Oh god, this is the worst. This is the worst. So it's like the time I tried to draw an umbrella and it was just inside out and upside down. Anyway, okay, sorry, I'm sort of interrupting with my terrible apologies for drawing badly.
It's great.
It's a yellow car. You've never seen a yellow car like this. If someone steals your bag and takes it, then...
The policeman finds this couple. They're called Malcolm and Janet Collins, and they fit the description. And so he's like, well, they must be the right couple. And he arrests them. And he tries to prove that they're the right couple, but it doesn't go so well because they sort of have alibis, but they sort of don't. They don't quite remember what they were doing on that day. You know, their jobs don't quite remember what happened on that day. Neither the woman whose bag was stolen nor the guy in his garden can pick them out from a lineup, so that doesn't help. Everyone's arguing about the girl's hair color, whether she's the right shade of blonde or not. It doesn't go that great, but he decides still, he's so sure it must be them, that he's gonna actually take them to trial. So they go on trial, and the prosecutor shares the policeman's view. He's like, this description is so specific and we found a couple that matches it, and so there's no way they're not the right couple. And he's trying to get this point across to the jury. And the way he decides to put it across to the jury is using maths. So what he does is he writes a list of the descriptors for the couple. Are you ready? So the first one is black man with a beard. Might take a while. Maybe we can just do the first three.
Okay, there's a lot of descriptors because they've got a lot of things they've noticed which might or might not be important. Like people in the chat being very mean about my car.
I love your car.
So he lists up descriptors. Okay.
I'm sorry, there's also building work happening in my house. This is really ideally, yes.
So I guess one of them is like the fact that there's a yellow car.
Yes. One of them is a yellow car. One of them is a man with a mustache. I'm not currently giving any judgment on this list. I'm just telling you the actual list. The next one is white woman with blonde hair.
Okay.
And then there's woman with a ponytail.
Okay, so this is like a list of things that they've noticed match between the description and the couple that they found.
Exactly. So, and then he assigned probabilities to each of these individual characteristics. The probabilities for black man with a beard was 1 out of 10. For a yellow car was 1 out of 10. Man with a mustache, 1 out of 4. White woman with blonde hair, 1 out of 3. And a ponytail, 1 out of 10.
Right, something already seems slightly dodgy, or maybe of the time. I think 1986, moustaches big in the 80s. Yeah, 1 in 4 seems really high to me. But,
seems very high, yes.
I don't know, but I guess maybe it was the 80s. It was the 80s.
It was actually the 60s.
Oh, sorry, I'm mixed up.
68.
Oh yeah, I'm an idiot. Sorry, but there's a long list of these. So far, we've got 5 of these.
There's actually just one more, so we might as well write it. The last one was interracial couple in a car, 1 out of 1,000.
Interracial couple in a car?
Yes.
That's so weird. That doesn't even feel like it belongs on the list.
No. And so at this point, after having given the jury this list of descriptors and assigned probabilities to each of them, he was like, so now to get the probability that all of them are combined together, we multiply all these numbers together and we get 1 in 12 million.
Okay, just multiply all these things together, 1 in 12 million, you say, okay.
Exactly. And he's like, well, that's a really tiny probability. There's surely only one of these couples in LA, and I found them, and so they must be correct couple. And this argument convinced the jury, so Malcolm and Janet Collins were convicted. Yes. Janet was only convicted to 1 year in prison, so she decided to just do it and get out after a year. But Malcolm had a prior conviction, so he got a longer conviction and he decided to appeal. And lucky for him, his appeal fell into the hands of a very smart law clerk called Lawrence Tribe, who eventually became very famous and powerful and worked for Obama in his administration. At the time, Lawrence Tribe was really young in his 20s, but he had studied math at university before becoming a law clerk, and he immediately spotted a bunch of things that were wrong with this mathematical argument. So I don't know if you
Chat.
guys want to have a guess.
Chat has put a couple of guesses in while you were describing. I think
Yeah.
we're indignant at this idea of multiplying together these numbers, and I'd like it if people criticise these numbers a bit more. Somebody's asked, will this stand in an international criminal court? And I don't know what level the ICC is, but it sounds like it didn't even get that
Yeah,
far.
it did not.
So a couple of people have used words like independent. Shrista said compounding of probability. You can give people more chances to explain why multiplying these numbers together might be a bit of a weird thing to do. In particular, if people want to pick a pair. So if you think these are not independent,
Yes, that's exactly it.
right.
If you think these are not independent, suggest a pair that you think is not independent. We can discuss
Yeah.
it. While you're doing that, I'm gonna give you the first problem with these numbers, which was that the way the prosecutor came up with them was by asking his secretaries what they thought.
I mean, really? Okay, so just a quick pop survey. How many people do you think have moustaches? 25%.
Yes.
Brilliant. Okay, so like source. So all of these are like citation needed.
Yes.
Okay, okay. Um, it always says there are more than 12 million couples in the world, which is a different criticism of this, right?
Yes,
So
this is
12 million is not that,
that's
not that much.
no, it's not that much. I mean, I guess LA at the time had fewer people in it, but even then, 12 million had more, probably had around. I mean, it wouldn't be surprising for there to be two of those couples at least, you know.
Mm.
Do we
Mm.
have any suggestions of
Two's
pairs?
enough, right? Because it could be the other one.
Exactly.
People. So people. I think. Yeah. Okay. So the two. People are trying to. People are trying to pick up which one. I'm going to pick up two from chat. People talking about the beard moustache combination.
Yes.
Okay, it's the 60s, but can we imagine people with
So,
a beard but no moustache?
yeah, that's obviously pretty rare having a beard and no mustache. So having a beard and a mustache are completely not independent from one another. That's definitely one. Um, Also, having a ponytail just shouldn't be on the list at all because that's not exactly a defining characteristic.
Right. This one, I guess, yeah. I guess anyone could buy a yellow car, and it's sort of, this is like not
Yes.
fixed, or not really something you can say about someone that they
No.
have a ponytail. Okay, I like that. People have pointed out. It depends what you mean by some of these, and there were a couple I really paused on of like, what on earth are you counting here? But like even on its own, but people in chat think that interracial coupling car is kind of implied, or at least overlaps with black man with beard, white woman with blonde hair, and if they've got a car, then between those, maybe it's sort of like there's a combination of these
Yes.
where you already had
Yes.
the information.
Definitely. I mean, there's really a huge amount of problems with this list that are very easy to pick out, and the defense lawyer did pick some out, but he focused on really the wrong ones. I'm not even gonna say what he said because it manages to be both racist and sexist. So he did not pick the right things to highlight, and he didn't manage to convince anyone. But someone who understands mathematics a bit better, like Lawrence Tribe did, can see right away that this is really just an awful list on very many levels. And Lawrence Tribe wrote a very good rebuttal that became a very known document. And he actually went quite far in his rebuttal, saying that he thought that these types of mathematical calculations should not be used at trials at all because the people involved in trials, just a random jury or even clearly judges and prosecutors and lawyers, didn't understand the maths well enough to treat it in the way that it should be treated. And this letter that he wrote, this document he wrote, had a big influence. So actually, it sort of stopped people from trying to use math in trials, at least in the US, for a really long time, pretty much until DNA analysis started happening and maths had to make its entry back into court.
Miles in chat suggests if one side brings math up in court, then the other side should be entitled to a mathematician. And I think this is foreshadowing, perhaps. It appears to me maybe Miles believes that if a mathematician is on one of the sides, then the mathematician will not make bad maths arguments.
Yes, I mean, that's so really a solution. Well, one solution would be obviously to have good, at least probability education in school. But another solution would be to have mathematicians as expert witnesses. And the next case I'm going to talk about, there was a supposed expert witness who did some math, but he was a doctor. And people are like, oh, he's a scientist, good enough. Like, we believe his maths, but probably super complicated.
I think one of the cases in your book
having
includes...
mathematicians.
Oh, sorry, I'm sorry to interrupt, but as well as the doctor, there's someone closer, right? Because does one of the cases in your book have Thorpe, the mathematician poker player, in there as well? Makes an appearance in one section.
He does.
Not in a very good light.
No.
Maybe not on the right side.
Well, not on the right side. I mean, yeah, there's also just the fact that if you know maths more than other people, you can use it for bad. And that's also something we want to stop.
Right. Before we move on, I sort of wondered whether it's worth... We mentioned maths education and whether it's worth highlighting a bit of maths that people learn at school that, I don't know, maybe touched on this. I mean, I think this argument is unfixable. I don't think you can take attributes because of something we haven't discussed as the kind of selection bias in that, for example, shoe colour is not on the list. And maybe that's because nobody saw the shoes, or maybe it's because the shoes don't match. That the person assembling the list has control over what random stuff they've put on the list, and I think that's really deadly.
Yes. The selection bias, like how you called it, actually is a big part of one of the other cases in the book that it's quite a famous case, that one about a nurse who was accused of killing babies that she was in charge of in a hospital. I know there's been a high-profile case recently where the nurse seems likely guilty, but in this old case, it was shown fairly conclusively, actually, that she probably wasn't guilty, and selection bias had a big influence in the calculations that were made. People tended to only look at the days she was in when something had happened and forget about all the time she was in when nothing had happened, for example.
Yeah, so these cases of once you start examining something, it's almost sort of the paradox with the cat that's dead and alive, and you don't know until you look at it that as soon as you start observing something, you're observing it for a reason, unless you're somehow observing absolutely everything. I've put Bayes' law on the board, just in case anybody needed a lot of Bayes for A and B. People in chat are talking about... Somebody's dug out census statistics for 1968 LA. So that's above and beyond. hardworking maths club here. And they're looking up numbers of couples. I think they're trying to interrogate that last number, but I'm not sure what they're going to do about in a car, because I'm not sure the census records whether or not you're in a car.
They own the car.
Or they have a car. Okay. Maybe the census does
At
it.
least having a car makes, or unless you've rented a car, no.
I don't know.
No,
We've
the
got
inner car makes
Ponytail on the list.
absolutely no sense.
We've got Ponytail on the list. So I think a sensible defence would be, Your Honour, in the crime they were in a car. Now they are not in a car, so they're right out. Right, they're right out.
Yeah.
You fight fire with fire. Right. Okay. Chat's bouncing around quite a lot. Good. Okay. I think you were trying to segue, and I stopped you with Bayes' law, but you were trying to segue to a different case, right?
Well, yes, because I just wanted to. Obviously, this case is from the 60s and it's in LA. And I just wanted to say that basically the exact same mistake of multiplying together properties that are not independent was made much more recently and in the UK in a super high profile case. So it's not, something that only happened back then. And this was at the beginning of the 2000s. And it's the case of Sally Clark, a mother who had 2 babies die of cot death. Cot death is when a baby dies before they're 1 year old and the doctors don't know what happened.
Yeah, this is a really sad case.
And it's a really sad case. And she was accused of having killed them. And there was absolutely no evidence. The only evidence was this guy, Romero, who was a doctor and an expert in cot deaths, saying, well, we have a lot of studies about the probability of a cot death happening in a family like Sally's, which was quite a healthy family, with none of the risk factors associated with cot deaths. And so he said the probability of a cot death in a family like that is 1 in 8,500. And so the probability of 2 cot deaths happening in that same family, you just square that number, and you get 1 in 73 million.
Right, so if something happens once, the odds it happens once, then maybe to find the odds it happens twice, we square. And I guess maybe some things in life work like that, right?
Yes. Well, if you have a boy and then you're pregnant again, the gender of the next child, the biological sex of the next child, is those are independent.
Right.
But in this case, a cot death, well, we don't know what causes a cot death. It might be that they both had a genetic marker that the doctors didn't spot. It might be that there was mold in the wall that no one spotted. That there are really a lot of reasons that make it pretty unlikely, actually, that they're independent from one another.
Right. I suppose there's sort of also the argument that the prosecution's making, of course, that there could be a reason why this isn't a random process. But if you can think of any other reasons why it's not sort of random chance, then that sort of undermines it, whatever the number is. But,
yes.
I think you said 8,500 squared. That's a huge number, right? But
it is 1 in 73 million.
73 million.
But again, you would still expect that to happen.
It's terrible.
In England, you would expect it to happen, once every few years. So even then, it might have just been complete chance that it happened to Sally Clark.
Yeah, and this one, by being more modern, I guess, and being in the news recently, this one has got a lot of coverage.
Yes.
Yes, people have suggested a genetic link between these and other related cases.
Yes.
Yeah, I was thinking because chat pointed out while they were looking up the census statistics for the previous one, trying to work out if is that a large number, which is something.
Well, that's a very interesting question, and it's called the Prosecutor's fallacy.
Ooh.
Because it has come up in law a lot. Yes. So if you have, say you're in the UK with 60 million people and you're like, this only has a chance in 5 million to happen. That sounds like a really tiny chance. But in the UK, it's going to happen, a good 10 times.
It's like winning the lottery, isn't it? It's amazing if it happens to
Yeah.
you, but not uninteresting if it happens to just someone.
Yes.
Sorry, that sounded really bitter, like I've lost the lottery recently, which I guess a lot of people have.
Yeah.
We should do something about this. I was trying to think of other things. The other things that come truly random, like being struck by lightning. But then I remembered. So being struck by lightning has some probability. It's quite hard to calculate, I guess. Do you know about this? Do you know where
No,
I'm going
but
with this?
it would be the same, or lightning striking twice. It is gonna strike twice
Yeah, lightning strikes the Eiffel
somewhere.
Tower all the time. The Eiffel Tower gets hit by lightning really, really frequently. But there's also some guy.
Right.
I should have looked this up. Who's been struck by lightning 8 times in his life, which
Really?
should be impossible
Well,
in
that's
funny quotes or something.
yeah.
But
So that could be just random. He's very unlucky, or maybe he just really attracts lightning.
yeah, and maybe if I give you some details about his occupation and his his occupational do it. So he's a
Yes.
park ranger in large open
Oh,
spaces
right.
in Canada. That'll do it apparently.
That'll do it.
Um,
I mean, there's a relevant thing with these types of cases where people are like, okay, so the probability it happened randomly is really tiny. But what is the probability that someone is a murderer or that someone, will kill their baby? That's probably even more tiny. You're comparing two things with tiny probabilities.
oh right, okay. Is this like? Are you making the point this is like a kind of false positive, false negative kind of
Yeah.
thing, where if you've got an ironclad way of detecting,
Yeah.
I can't quite hold it in my
No,
mind.
it's
Sorry,
tough.
you've got to catch. I'm making it silly, which is not really right, but you've got to catch some murderers, but there aren't very many murderers.
Yeah.
So you put them all in a lie
No.
detector test. Is this the way this works, right?
Yeah, exactly. That's exactly what we should do.
Right, you put them on a lie detector test, and your lie detector test is like 99% accurate. It's very good. Um, but then this is a huge problem, right? Because
Yes.
if you put everyone in the lie detector test, you should ask them, are you a murderer or not? And you'll find, well, the murderers can't escape because whatever they say, the lie detector will catch it. But also 1% of the normal people who are not murderers will also, the lie
Yes.
detector screwed up in those cases. And they massively outnumber, this is it, isn't it? The 1% of normal people massively outweighs.
Is actually a huge number compared to the very small number of murderers. Yes.
Right, so maybe we should be
I
comparing
think that
this.
works.
We probably shouldn't be engaging with the 73 million number really at all, but we should be comparing it to some sort of purported murder case. Murder. I suppose we don't really know that, do we? Or depends how many murders.
No,
I've gone
there's
deep.
no way of knowing.
I've gone deep. What percentage of
There's no way of
murderers do we
knowing.
catch?
Yeah, exactly. Some people think a lot, actually. Some people think it's very hard to commit a murder and get away with it nowadays. So
Okay.
maybe we catch most of them.
PSA for chat.
Yeah.
Very hard to get away with. Emo tells me the guy was Roy Sullivan, and it was 7 times struck by lightning.
Okay.
Part of the remarkable thing there is surviving it 6 times.
Yes.
Anyway, okay. Did you want to say more about Sally Clark and Prosecutor's fallacy?
No.
Oh no, internet. We had this a little bit in the warm up. The internet connection is not perfect. It's possibly my internet connection, in which case no one can hear me. Oh, Coralie's back.
No, I'm back. I'm back. Sorry, it's me. It's but normally it works, and I only cut out for a couple of seconds. I was saying that I'm very happy to answer any questions if people have questions, or to talk about another case.
Let's ask chat. Chat's talking about Black Swan events. I'm not sure I've heard that phrase before, but the anonymous person in chat says meant to be so infrequent but happens somewhat often.
Yes, that's exactly is exactly the prosecutor's fallacy, is when a black swan event is something that is really, really unlikely to happen, but happens. Is it going to happen? A lot. That's something that's really unlikely to happen happens. People get very confused by black swan events because we can't help ourselves. This is actually related to the next case I wanted to talk about. You can't help yourself from thinking about it in terms of, oh, what if it happened to me? But no one cares if it happened to you. It's just about something happening in the
I care
world.
if it happened to me, but you're right. Nobody cares. Nobody
Yeah.
cares if I win the lottery. That's the sad truth of the world. Um,
Not nobody. Most people.
Question in chat: did this happen during COVID with false positives and they're asking about false positives and false negatives?
Yeah,
Um,
a lot. The COVID tests were really good at finding positives. But even when a test is really good at finding positives, there are a lot of false positives. And then no, what were they? They were really good in one way. No, they were really good at finding negatives. But even if a test is really good at finding a negative, there'll be a few cases where you're positive but test negative. And then they were quite bad at finding, well, there were a lot of false positives, basically. Oh my God, I'm really getting myself muddled.
yeah, chat can work out. It's a sort of homework exercise. Work out which way round would be better. Would you like a test that's really good at never being wrong? I guess the extreme is a test that always says COVID or a test that never says COVID. Those things
Yes.
make a lot of errors. Would you rather it be at one extreme or the other? I'm
I
not
think
sure.
they were bad in the best way, actually. Like if they told you were negative, you were very much likely negative, so you knew you could go about your daily business.
Um, People will try. Anonymous person asked about financial crashes. There's no financial crash stuff in your book, right? Or
There is not the only thing related to a financial crash in my book. I don't remember the details of this case super well because I haven't looked at it for a while. But it's this woman, Hetty Green, I think she was called. She was like a finance like a genius. She did completely fine during the crashes, and she was this crazy woman who dressed in like always like really dark long dresses and was actually really miserly in her life, but was a complete financial genius and made loads of money. And she made loads of money by investing really well, but also by just pinching every penny. She would even reheat her tea on the radiator and that kind of thing. And there's a case in the book about her because even though she was worth way, way more money than this, she was really angry when someone in her family left money not to her. And she, I think, was accused of forging a sort of affidavit to the will that came out later in the trial or something, that said actually the money should go to her. I think that was the story. And so then there was a calculation about the signature. The signature was basically much too similar to the other signature. It was basically exactly the same as the other signature. And so there was a whole calculation about how likely that was to happen randomly or whether she must have forged it.
I love the ones about things being uncannily good, like
Yes.
suspiciously good. You see it in statistical fraud on. Some people think that a person with the genetics of peas might have made up some statistics that are just too good to be true because
Yes.
they're so perfectly proving the point. A couple of people have asked, how did you have the idea for this book, or how did you get to combine maths and the law? You've mentioned that your parents are mathematicians, you did maths at university,
Yes.
so I guess that half.
Yes. That's one half. Yeah. Well, so basically, my mom is great. She's extremely energetic. She does about 5 million jobs. So on top of being a full-time mathematician, she's written a lot of detective novels and she's now actually an expert witness, a mathematician expert witness in France. Yes.
Aha! As suggested in
Aha.
chat.
Yes. She actually got her French nationality just in order to be able to do this. So she's been doing it for the past year or so. And when I was 22, I told her, "Oh, I'm just gonna go to Argentina for a few months and party the whole time." And she was very unimpressed with this idea. And she said, "Fine, but at least we have to write a book."
That
So
was the
that's
deal.
how it came about.
That was the
That was the
deal.
deal.
Post university party in Argentina, but also we have to
Yeah.
write a book, and it's going to be about one of your mum's interests.
Yes.
Okay.
So we originally were just thinking of doing a general mathematical errors book, but we found a few that were related to court cases, and we thought, well, this is actually super interesting. And by finding a few of them, we were able to, like, we knew better what we were looking for, so we were able to find more less famous ones, and it was really fun. I was like calling up, places in the middle of America and getting them to fax court documents and that kind of stuff. The research was fun.
Nice, cool. I would like this. Almost became. I like the idea that you were almost writing Humble Pie and Matt Parker's sort of mistakes. Although
Yeah.
Humble Pie got more of an engineering kind of flavour. I'm not sure if I'm putting Matt Parker in a box there too much. It's got a plane on the cover with wings on backwards, which I now realise it's not a good example.
I will read it. I'll read it. I haven't read it yet. It's waiting for me, but back in France, and I'm in Mexico.
That's a safe reason. Sorry if I've embarrassed you in front of Matt
No,
Parker.
it's fine.
Do you want to talk about another case, or how
Yeah,
are we playing
sure.
this? Yeah, okay.
Yeah.
Sure. I hope I get to do
Do
another
people want to
drawing.
hear about another case? You can help me. You can help me with drawing a DNA profile.
Okay, DNA. I can do
Okay,
that. Double helix. I'll start now.
great. So this case is actually again in California in the 60s or 70s. And it's a murder case. So sorry, that's a bit violent, but this young woman, Diana Sylvester, was murdered, and her murder was never solved. So the file went into, a dusty office. There happened to be a DNA sample from the murderer, so the DNA sample was kept there for a long time, like about 30 years, until DNA analysis was invented. And California got a grant to reopen any cold cases that included samples of DNA, because we now had this new technology and maybe the cases could be solved. And Diana Sylvester's murders was one of the cases that got reopened. The DNA sample that was held in the file was really degraded. And so, thanks for this great drawing of a helix. And now, can you please help me with a drawing of a DNA profile? So what it looks like when you're testing DNA.
Does that mean the sequence of letters that
Which,
DNA is made up of,
yes.
right?
No,
No.
it should look like a sort of very low squiggly line with occasionally two peaks next to each other, and then again low squiggly, and again two peaks next to each other. Yes,
What's this measuring?
exactly.
Sorry, this is.
So this is called an electropherogram. Oh my God, I was saying this completely wrong. That's the DNA electropherogram, and that's what someone's DNA profile looks like when you put their DNA through a computer and you look at it.
So hang on. So
So
there's some sort of scanning.
yes,
I know a tiny bit about DNA sequencing. Maybe chat knows more than me. But how you do? So is this recording the information that's on the DNA, right? Which is
yes, and basically they've identified 13 different things on the DNA that differ a lot from person to person, and so those 13 things, those 13 pairs of peaks, are enough. If you have all 13, they're enough to know that if two profiles match on all 13 of these pairs, they're definitely the same person or identical twins. So the probability of matching on all 13 pairs is something crazy like 1 in 300 billion or something like that.
Wait, if they're independent and if you multiply them together.
And they're independent.
Okay. Is this all right? Okay.
Yes, they are independent.
Okay, so we've got all the ingredients for case. We've got a cold case, murder,
Exactly.
we've got new technology, we've got a science machine that says bit,
Exactly.
bit.
And we have a DNA sample that is very degraded. It only has 5 of the pairs of peaks on it, not all 13.
Okay, that's not really a passing score, is it?
No. But still, they take the sample and they run it through the database that they have of everyone who's ever been convicted of a crime in California, and they get a match.
Oh. On
Yes,
5 out
and
of
the match
13,
is
though. Okay.
yes, on 5 out of 13. So you have no idea what happens on the non-5 out of 13, but you know that he's matched on 5 out of 13. And The guy is called John Puckett. He's also of a reasonable age to have committed the murder back then. So they decide there is enough to take him to trial. So what happens with degraded DNA samples is that you still have probabilities. The FBI, well, the scientists have given to the FBI the probability, what they think is the probability of matching on a smaller number of loci. Loci is what you call a pair of those peaks. So what the FBI has as the probability of matching on 5 loci is 1 in 1 million, pretty much. 1 in a million, which, if you're looking across a whole country, a big country like the States, is actually not super good.
Is that a big number again?
Yeah. So that's one question. Is that a big number? So that was one of the big discussions that came up at John Puckett's trial. And by the way, I'm going to do a bit of a spoiler alert. We don't get answers to any of the questions because John Puckett died during his trial. So it was the whole trial was abandoned. He was old and ill. He had a perfectly fine life before then. But yeah, we didn't get any answers in that story. But we did get a lot of questions and a lot of discussions. And one of them was about this 1 in 1 million. Is that actually a big number or not? The second one was completely different. John Puckett's lawyer was actually really worried about these numbers that the FBI provides for the chance of matching on a smaller number of loci. She thought that the FBI had the numbers completely wrong. And the reason she thought they had it wrong was because she had access through a scientist friend of hers to another database where they were doing some DNA analysis. They were just matching profiles. And in this really small database of just only 60,000 people, they had found a lot of matches, like over 100 matches on 9 loci. That was the number that they were observing in this database. And supposedly the probability for 9 loci, the probability as given by the FBI, was 1 in 13 billion. So in a database of around 60,000 people, the lawyer said, well, you wouldn't expect to see any matches. And instead you're seeing 120. So that was one of the things that got discussed at trial. And this is exactly the birthday problem. So I don't know if people in the chat are familiar with the birthday problem. I would imagine that probably a lot of you have heard of it.
I'm trying to remember if you've done the birthday problem on the stream recently. 2 questions while they're thinking about the birthday problem and how that relates to this. I wanted to label these. I think you're calling them loci. Is that
loci? LOCI.
Okay. And is it 5 out of 13? Hang on. So an anonymous person in chat asked. I think it's a good question. I'm going to read it out. Are the 5 peaks any 5 of the 13? Or is it like a specific 8 of them are corrupted?
Yeah, so that's a really good question.
Does the order matter?
It slightly matters. The probabilities, the FBI's probabilities are actually very specific on which of the peaks you have and which ones you don't have, but they don't change a huge amount. I mean, they're all going to be around 1 in a million for 5. But yeah, the FBI does have the very specific probabilities.
Okay, so the birthday problem, Zoe's put a description in chat. The one that people often call a paradox, where the thing where it's actually like 23 people you need in a room to share a birthday is...
Exactly. So this is it. How many people do you need in a room to share a birthday? It's only 23. It's super low. How many people do you need in a database to find 100 matches on 9 loci? It's the exact same calculation, and the number happens to be exactly what the size of the database was, which was around 65,000 people.
Right, it's something like the square root of the number of possibilities. So there's 365 days that your birthday could be, and I think the
Yes.
correct intuition, which no one has, is that it's about square root of 365 before you are very likely to get a match between 2 of them. I'm slightly behind though. Sorry, don't know if chat's way ahead of me, but that's a match
No,
within the
that's fine.
database between. So there's something there about whether two people in the database match each other, but don't we
Yes.
care about
So
matching this specific
exactly.
one from the case?
Yes, exactly. So that's exactly what happened. So remember the person who was bringing up this question, thinking the probabilities of matches themselves were wrong. And she thought they were much higher than what the FBI was saying. She was John Packett's lawyer, and unfortunately, her argument was not relevant in this case because, well, she was thinking about the wrong birthday problem. She was thinking about the birthday problem of any two people in a room instead of the birthday problem of someone sharing my birthday. And this mistake did get caught by the prosecution team. And it's quite funny because both my birthday and my mother's birthday get mentioned in this case as important dates. So there you go. Lots of
Spooky,
birthday coincidences.
or not spooky? I'm sorry.
Yeah.
I thought I'd misunderstood, but it turns out it's so disappointing that the birthday paradox thing came up in a court case, but not one in which it was a sensible
No,
argument for that size to be making.
no. It is sad. Though I did find it really cool doing the calculations on we actually did the calculation the other way around. We calculated if you have a database of 65,000 people, how many matches would you expect to find? And it was really cool to find that it matched exactly the number of matches that they did indeed have. You know,
Okay.
it's nice when you it's nice when it works
I've got to think.
as it should work.
I can sort of see how you do that calculation. I guess you've got to know the size of the kind of sample space, or what these. You've got to know a bit
Yep.
about these loci, right? You've got to know a bit about what the data could be, what constitutes a match. Um,
Well, actually, you have the probability. We were just testing out whether we thought the FBI's probability was correct. So we just used exactly the figure that they gave.
oh, okay, okay, and you can run it because you've got the number from the separate database as well, so you can compare it
Exactly.
there.
Exactly.
Okay, trying to work out if you wanted to do the birthday problem with something else, like how many people do you need before it's likely you've got two of them wearing the same coloured socks, then I guess I need to do some data on socks.
Yes,
Um,
exactly. You need to have that probability to start it off with.
okay, cool. I'm still gutted that really good
Yeah, I'm
paradox came
sorry.
up
I'm
at a point
sorry.
where
And it is very frustrating. We don't even know what happened at the end of the case and everything. But it's pretty cool that the birthday problem gets discussed in a court trial. I thought that was pretty cool. And in this case, the prosecutors figured it out correctly among themselves. At least they didn't let the error, keep going.
so in a way this was a case where the bad maths was on the side of the defence.
Yes.
Other two we think were bad maths on the side of the prosecutors.
So there was another argument, but they never decided whether it was bad maths or not. But the other argument was exactly, well, sort of what you were bringing up about is 1 in a million a big number or not. John Puckett was found, he was in a database. They had 300,000 people in the database this was a database of offenders in California. So the pros no, the defense team also said, well, okay, if there's 300,000 people and the probability is 1 in a million, well, you're pretty likely to find someone actually. So then the conversation became about, okay, well, what's the probability of finding someone whose other defining characteristics also match what we know of the murderer at the time, because the murderer had been seen at the time. Someone had
Okay.
seen them and knew what age they were and all that kind of stuff.
It's kind of the rest of the case and the rest of the kind of
The rest of
normal
the case.
evidence that you might do. Um,
Yes.
I
But
think
really, if you have a DNA match on, a really good DNA sample, then you don't really need any rest of evidence apart from knowing if the person has twins or, is a triplet or something. But once you get into degraded DNA, then you need to know a lot of other stuff. It's just one thing amongst many, which I think a lot of people don't realize about DNA. People tend to think, oh, a DNA match, that means it's them.
it really depends. So someone asked about whether the degradation happened at random, and that sounds like a hard science question. Um,
Yes, and I do not know the answer.
right? Yeah. We've got about 5 minutes on the clock, and I kind of want to talk about Clara Valentine as well.
Yes,
if we
great. I would
can.
love to talk about Clara Valentine.
Okay. People can put questions in chat
So,
if they want to talk about birthday problem or something.
Clara Valentine is another book that I wrote on my own this time, and it's aimed at people your age actually. It's aimed at people between 15 and 18 who are interested in maths. It's a it's like a fun mystery story. There's a group of kids in school who are trying to find someone's brother who's disappeared. And there's a lot of maths involved. Because the brother who's disappeared is this computer genius, and in order to keep his little brother out of his computer, he's made it so you need to answer some maths questions to get in. So they're trying to get into his computer, and they have to answer some of my own very favorite maths problems. One of them is the birthday problem, but there's a lot of other stuff.
No spoilers, but there's things in there about irrational numbers and
Yes, the maths is really, really some of my favorite stuff, and it goes, it goes into university level maths. It's like beautiful maths. It's great maths.
and it's in the format of a diary, sort of, right? Or the concept is called the
Yes.
diary. It's
Yes, it's a diary. The main character is a girl, Clara, and the person who's disappeared is the brother of her crush. But to complicate things, she does have a long-term boyfriend, so
I'm putting the tags. Don't worry, I've got you. We got mystery, maths, boyfriend. These are all the things the publishers want as well.
yeah. It's
I-
really fun, and I really enjoyed writing it. And I always love it when people come across it, which unfortunately is on the rare side because I self-published. I talked to a lot of publishers about the book who were interested, but they all wanted me to change things about it, including sometimes take out the maths. So in the end, I just decided to self-publish.
Yeah, I like that. I don't know. I haven't checked if I can read this, but on the back of the book, you've put some pull quotes where people might
Yes.
put quotes from just anyone to endorse the book, I think. But I really like that you've put quotes from your sister, quote, a real life teenager, and a publisher who didn't publish the book, who have nice
Yes.
things to say about you. I just like that you've included your family in there on the back. If I hold it up, can people see?
Yes.
I have the book.
They were my first readers. I will say, because this is one of the things that meant publishers, what that publishers wanted me to change, that there is some sexual content in the book, which is very age appropriate, in my opinion, my French opinion, at least. But just so people are prepared.
Okay, content warning. Maths.
Content warning.
Oh, what's the one on XKCD? Warning, this webcomic, this XKCD says, warning, this webcomic contains math and romance. I have a copy.
Yes.
I have a copy. It feels slightly odd reading it for me because it feels, you've got the genuine voice, it feels like reading a teenage girl's diary. Which does make me feel weird, but
Well, that's good.
but it's also got maths.
I mean,
in it, which-
it's probably good that it makes you feel weird now, but it's good that it genuinely feels like reading a teenage girl's diary. That's great.
Oh, not
That's
that,
what I
not
was
that.
going
No, of course. Okay, smashing. We always do further reading notes for these episodes when we can. Last week I had to write extra notes about Infinity and killing a Hydra. Those posted on the Math Club website. We'll put links to, I think your website has got information about both your books and other stuff.
Yes, it does.
Is there anywhere else that people can find you if they want more Coralie comments?
Well, if your school uses Unifrog, just gonna go. If your school uses Unifrog, we've just launched a new thing that I'm so excited about, which is our own online courses, which anyone who has access to the platform has access to. And I personally wrote 2 maths ones, so you can check those out.
Cool, good plug. I'm going to plug my Twitch if we're doing plugs. If you want to catch more James Monroe, you can catch me. I'm here every Thursday, but I also stream on Twitch on Sundays. You can find the further reading and over 70 previous episodes of this show on the Maths Club website. I'm talking, I think, to the audience, but Coralie, if you want to see 70 episodes of this, they're on there as well, which is also where people can find out about Jane Street and the Mathematical Institute, who support this show. I'm pausing slightly in case chat wants to ask anything, but chat is mostly telling me off for what I said about diaries. So I think we'll wrap up there. Thank you very much for coming on the show, Coralie.
Thank you so much. It was great.
Thanks for people watching.
Oh, and if anyone has questions, you can contact me. My email address is on my website and everything. I'm very happy to answer them.
Zoe is just in chat has said, thanks for work on Unifrog. It's been very helpful for our class. People want the book.
That's great.
We'll put links to books, I suppose.
Oh, you can buy the book, which obviously is very nice for me. And also I designed the cover myself. So that's, but you can also read it for free. I've also put it for free on my website.
You did get control over the cover of this one. Yes, I wasn't sure if we were going to mention that you've got the free version on your website.
Yes.
We will link to, now you've mentioned it, we will link to the free version of your book on your website. And the Amazon version in case somebody wants a physical, let's model it one more time, a physical copy of the book. Right, good. Everyone says thank you, and I'll say thank you as well. Thanks for coming on the stream, and I'll see some of you in 167 hours for another episode of the Oxford Online Maths Club. We'll be back 5 o'clock this Thursday. Bye.
Bye.